Left there probably 10 or 12 years ago, and since then I've got a little bit of a toy farm we play around on, run a few moves, and do a little bit of consulting, do a bit of training for young people, and trying to teach them the trade. One thing, there is a bit of a dearth of soil conservationists around. There's a really high demand for it. John and I are still getting plenty of work, even though we're getting too old for the job, but anyway, we're getting there. So the basis of my talk is about the erosion process and the theory behind stuff. But why keep your soil? That's Bryce Canyon over in America. If you want to see erosion, go and have a look at the Grand Canyon, Bryce Canyon, you know, millions of years of erosion. What's it do? It makes spectacular scenery is what it does. It's not much good for the country, but it's spectacular scenery. But for you blokes, why keep your soil? It's the basis of your business. That's what you build your business on. That's what grows your grass, feeds your cows, or your goats, whatever you're growing. It's the basis of your business. So you've got to keep it, look after it. So soil erosion types starts from the minor and heads up to the big stuff. So increasing level of soil loss per unit area. You've got raindrop splash, and I'll go into that a little bit more, where the raindrops hit your soil and then just splashes it downhill. Then as you get more and more runoff, you start to get sheet erosion. Just shallow flows, and then when you get enough concentration of those flows, you start to get rills, and then they get more and more flow. They develop into gullies, and then into streams, and then you get stream bank erosion, stream bed erosion. And gullies can be quite major. So why do soils erode? This is the next one. So this is the sort of process. You start with rainfall. You get it hits the soil. You get splashed downhill. A little bit uphill, but most of it's, you know, because of gravity or whatever, it all goes downhill. You get enough runoff building up, and then you get it gets transported, and also translocated. It can roll along as well as being in suspension. All goes downhill, and when the slope drops and the energy gets out of the system, you start to get deposition and siltation. Righto. Move on. So how can we slow this process? That's a geological process. It happens. That's how come we've got the landforms, the topography we've got now. It's just been happening for millions of years. And it's just going to keep happening. But if you want to keep things as much the same as now as you like it, or what you've sort of got to deal with, you want to slow that process down so that you can control things. And you really need to understand what's happening so you can do something about that process. If you don't know what's happening, then you're sort of barking. You know, it's hard to do anything about it if you don't know what's happening. So there's 4 or 5 main things that affect erosion rates. These are them: rainfall, your topography, your landforms, your soil type, what cover levels you've got and what sort of cover it is, and then you can do your land management practice, contour banks or strip cropping or whatever. So they're the 5 main things that affect erosion rates, and we'll just work our way through those a bit. So rainfall, there's 2 aspects to that that's important: the intensity and the duration. But intensity is more important than duration. There's not a lot you can do about it. I mean, how it comes, there's nothing you can do about that. It just comes. God looks after that. There's nothing you can do about it, except sort of manage its impact. So raindrop impact, like I said before, that causes splash erosion. It hits your soil and busts up the clods if it's heavy enough. And those finer particles, when it busts up your clods, the finer particles can go into the pores, bung them all up, and you get less infiltration, more runoff. But even if you do maintain your high infiltration rates, sooner or later, the soil's going to get full of water and your infiltration rate's going to slow down. And once the infiltration rate is less than your intensity, or the other way around, intensity is greater than your infiltration rate, then you've got to get runoff. It's got to go somewhere. Yep. Also, another aspect of climate or rain or that sort of thing that's important is temperature and wind for drying out your soil, so that, you know, if a storm does come, your soil's a bit drier and it'll hold more water straight up. Soil's probably one of the most important things, and soils behave differently. Different soils behave differently. That's just an example of a profile of your soils. You've got your surface soil, then your subsurface soil, subsoil, and then the weathered parent material. What do you got there? Black soil, bertasol on that side. On that end, and more or less a duplexy soil on this side with a bit of a sodic looking layer, white stuff just in the subsurface soil. Jim says, talking about before, there's 9 main soil types. 9 main soil types in this area. And if you don't know your soils, you should know your soils. You can also get a bit of an idea of what they are on Queensland Globe, and Jackie Worth up the back up there. We'll show you how to use Globe and find your soil type on there if you can find it. So it's available, that sort of information. It's pretty broad scale sort of stuff. You might not exactly, if you point on your spot, you might not actually get the soil there, but if you look through all the different soil types, you'll be able to pick out sort of what you got. I guess that's probably a pretty fair assessment of it.
Yeah, there's a reasonable coverage. It all depends what... Yeah, there's a reasonable coverage, but yeah, I guess if you are interested, just go and see Sam, and he can pull up your property. And then if there have actually been samples there may or may not be information associated with those samples. But some of the samples might have quite detailed information, including all the chemistry of the soil. So a bit of potluck, but certainly worth a look.
Okay, what else have I got to say there? With regard to soil erosion, the sheer strength of your soil is the most important thing. You want to be able to maintain your clods, and they've got to sort of stick together so that you've got a good matrix of soil. And helping that is organic matter, humus, all the biota, the fungus, all that sort of stuff helps bind it all together. So you really want good, healthy soil. There is mineralogy tied up with it, and that comes to pass and be effective, particularly if you've got dispersive type soil. These are the things that your erodibility is affected by. Your infiltration and hydraulic conductivity. There's sort of 2 different things. Infiltration is just on the surface, getting your water into your surface, but then there's hydraulic conductivity, which takes it further down. The water holding capacity, just how much water your soil can hold. Yeah, and that's affected by those things there. Yep. And then you can get crusts and plough plans that reduce your infiltration rate. Silty and sandy soils are often more erodible than clays, but that's not always the case. And aggregate size distributions, the larger the better. Particularly the red soils, they sort of keep their aggregates together. Like black soil, good vertisoils, black clays, they will slump, disperse when they get supersaturated. Not disperse, sorry. They slump and become, when they're supersaturated, and that makes them highly erodible. But dispersibility is really, really bad. That gully there is in dispersible soil. Really, really bad. Yeah, that's just an example of a roadside cutting in a dispersible soil. Shocker. Length and slope topography. The steeper the slope, the more erosion you're going to get for the same amount of runoff. And the length factor comes in. As it's longer and longer, you get more and more runoff. And that's going to increase the kinetic energy and the stream power of your runoff. And that's going to erode, just pick your soil. It's got more and more power to pick your soil up and take it away, transport it out of the system. Next one, cover the management. Like the cover, from an erosion point of view, it doesn't matter if it's stones or rocks or plastic, whatever it is, or vegetation. I mean, vegetation's the best from a production point of view, but from an erosion point of view, it doesn't really matter. And they're the things that it sort of does. It absorbs the kinetic energy of the raindrop. So when it hits, in that little diagram over there, when it hits the soil, it splashes up, moves it all downhill. But that effect, when it's about 3 raindrops deep, that sort of effect runs out. It's just hitting, the rain's just hitting water, so it's not really doing that anymore. But that's about 3 raindrops deep, which is still not very deep, but anyway. Righto. Yeah, that sort of stuff. Next one. The support practices. If you get too much runoff, you can run in contour banks, get rid of your runoff, but you need safe disposal areas for your waterway or your contour banks. That's on. Oh shit! Sorry. Wrong button. Sorry. That's flood on the floodplain down on the downs where we use strip cropping, sort of perpendicular to the flow. Try and keep the water spread shallow, keep it as spread as possible and slow, shallow. Thanks. Yeah, pondage banks. We put in some pondage banks back in the mid-70s and early 80s. And they weren't a real success. The whole idea of them being to hold the water up on your catchment and try and get more and more infiltration. And there's a couple of proprietary people around now trying to flog that system of holding your water up in your catchment. You've got to be really, really careful with your banks. You get cattle pads through them, they break. Yeah, high maintenance. So we really didn't go big on level banks. What else we got there? That's about it. Yeah, that's just some stuff about contour banks. The gradient, you don't want them too steep. We put them at 100 and 150 mils in 100 metres on most soil types. You go a bit steeper for short runs, and the more, the red soils, the more stable soils. But on brigalow country or good black soils, you wouldn't go much more than that, 100, 150 mil and 100 metres. The spacings, we've got the spacings here for different land slopes, recommended spacings, and that's for those spacings and for a length of 800 metres or 1,000 metres, kilometre long, that's the sort of dimensions you need to hold. That's for a 10-year rainfall event. Anything larger is going to go over. Like surcharge, they're only designed to do a 10-year for those dimensions, 10-year rainfall event. You can make them bigger and hold more water, that's okay, but you've got to do a compromise between costs and, what sort of protection levels you need. Waterways, natural drainage lines are better than perched waterways, and you need a well-grassed. Creeping type grasses, stoloniferous type grasses are the best in those. So to minimise soil erosion, reduce your amount of runoff. So you maximise your infiltration and your water holding capacity, any detention, hoof marks, whatever, anything in your soil, just to try and reduce the amount of runoff, get it into your soil. And then once you've got runoff, then you control it, either by banks or spread it or whatever. So yeah, that's about it. Any questions? No questions? All good?
We will leave the questions to later. I thought after hearing about the factors that drive erosion processes, we switch over to John. And John Day, he has been, thanks Jeff, we continue doing the Q&A panel later. But yeah, Jeff will be following on from Jeff's talk and talk more about, how can those erosion hazards be managed and rehabilitated, be prevented, and all that kind of stuff. So John has been working for nearly 2 decades, I think, for the Queensland government and other industry bodies, and most recently works as a private soil conservation consultant between Gympie and Townsville. But I'll pass over to you, so yeah, feel free to say a little bit more about yourself and delve into your topic.
Thanks very much. I'll just see whether this goes straight on or it does not go straight on.
I didn't consider that.
It's all good.
Introduce yourself and I'll sort this out.
Julian had it all right. I worked for DPI for 27 years, 12 years as a full-time soil conservation officer in Emerald and Mundubbera, and then a number of years in management and all sorts of other interesting things like economic development and a regional story, and then managing staff as well. Then after the big floods in 10-11, there was a demand again for soil con officers, and I took a redundancy from DPI and worked for one of the regional groups in the southeast, at the Burnett Mary Regional Group. So I've been working full-time as a soil conservation officer then for that period from about 2013 onwards. So got back into the old harness. So what I'd like to talk to now is go on from what Jeff said and add to and reiterate, I suppose, a little bit of what Jim's talked about. So cover management for improved infiltration. And to me, as far as soil conservation goes, it's about whole property erosion control. Is if you look at it in that context, you've got a good idea about matching your production to what you wanted to achieve. So points to consider is the topography has been mentioned. How steep the slopes are, how many. The soil types has also been mentioned, what your soils are, what your land types are. Your enterprise mix, whether you got cultivation, whether you got cattle, whether you got goats, whether you want to grow trees, all that sort of stuff. Management style, whether you're wanting to do intensive management, small paddocks, rotational grazing, or whether extensive. Your logistics, it's a huge issue around soil erosion. Access, infrastructure, that sort of stuff. Those things can really affect how soil erosion happens on a property. And your timber status and what's cleared, what's open, and where you leave shade lines, all that sort of stuff, and citing those things in your property in a property management plan are very important for overall soil conservation. And as Jim mentioned, the thing that we always put last, but it should go first, long-term business plan. What the hell are you trying to achieve with your property, with your business? How are you making your money? What's that mean? Do you want to pass it on to your kids? Do you want to build it up, sell it quick? Whatever. That comes first, what your goals are. Then you build your property and your business around that, with the underlying issue of soil conservation being the thing that props up your whole business, because you're working with your soil, as Jeff said, which is your main production creator. And as Jim also said, start with a map. You've got Queensland Globe, and you've got your cadastral information there. You've got topographic information. This is a paddock that some idiot bought, and that's the break-up of your fences. So you can very quickly get a bird's eye view of what your land is like, where you should be putting roads and tracks, that sort of stuff, where your drainage lines are, where your slopes are, your hills are. And so having that map to start with and having a look at that is a great thing to do. And of course, the other thing to do is to see how much veg you've got, what you can clear, what you can't clear. And if there's too much of these big blots there, you're looking in a paddock that size, you've halved your effective carrying capacity. So you need to check those things out and look at them logically. You might have 20,000 acres. If you look at the country you can't clear, you might only have 10 that's actually production at the level that you're planning on. So you need to take all that into account. But if we go back a step and look at soils, it's the engine room of all our production systems. So, as Jeff alluded to, soils retain water. Water grows grass. So, what is the plant available water capacity, as the jargon says, for soils and different soils, and what can affect that? So, you've got the influence by the content prior to water coming in, surface cover, surface structure, texture, and then you've got things like the organic matter, rockiness, and the rooting depth of your plant is an interesting thing to look at too, because most plants will only get down there about a metre and a half tops if you're grass species. Legumes can go a bit deeper, but no sense having a heap of water down here if it's, it's great for water storage in your water tables, but as far as your plants go, it's no use to you down there. So, what do soils hold? This is a really interesting little graph that I pinched from somebody, and it just shows you the different water holding capacities of different soils, which is something you wouldn't think about. Dirt's dirt. It holds water. It all holds the water the same, doesn't it? No, it does not. So you've got a well-structured clay, huge capacity, 500 millimetres per metre of depth. But when you look at the wilting point, or when the plant stops getting water out of that dirt, it's still got 300 millimetres left in there. The plants can't access because of the structure. If it cracks and breaks into PEDs, the roots can't access the water. So you've only got 200 mil in that really good clay that plants can get at. So an ordinary clay that's not cracking, again, same sort of issue, but you less water there, 140. This loam's a pretty tricky one. It back up the best available water of any of them. Hasn't got as much to start with, but the plants get more out of it because the roots, it doesn't have that cracking. The roots can get all the water out of the soil. Some of your red soils will be like that, the really good krasnozems. They'd be pulling every last drop out of there before the plants die. So you've got a better water capacity in that soil than your really good clays that the plants can get at. So sandy loam's less again, back towards the clay, which is pretty interesting in itself, sandy loam. You'd think that water would go through that. Get back to your sands and you've got virtually nothing. So that's really good to think about, what soils you got and how much water they can actually hold for your plants. Mind you, around here it's more about how much runs off, because there's that much of it. It's a bit hard on my eyes up here, coming from the Badlands down south where it's always brown. You get green blight. So ground cover and water, runoff. Next thing, once your soils are there, your next thing is your cover and your water runoff. So we've got the chart that's been around forever, and a lot of work done on this in the early days when they actually did science research on soil conservation. So if you got, the more cover you got, the more water you retain. The less cover, the more runoff. So 20% cover, you'll get 40% runoff. 90% cover, you only get less than 10% runoff. So that makes sense. And what does that look like? I got some pictures too, Jim. We all came from the same paddock, nearly. This is speargrass down in the Burnett. But that's, you know, you get 100% cover on a paddock like that. But unlike up here, we actually do get paddocks that have spaces between the grass tufts. So you're getting there about 50% cover. There's a lot of stalks and not much cover actually on the ground. And then back to your less than 30% that Jim couldn't find a photo of. We find heaps of photos of those down in the Burnett. So bare ground with tufts here and there, and the water's hitting bare ground like those raindrop splash that Jeff was talking about. So that gives you a rough idea about what those covers look like. The other thing is the infiltration rate, and it helps to, the more cover you have on, the better infiltration you get. It's not quite as dramatic as with the runoff story, but again, the cover, is helpful to improve infiltration. As you can see from this one, it starts at about 20% cover. You increase your infiltration significantly, and it doesn't make a huge difference after that, but it still is important to get that water in. The other thing that Jeff mentioned is what's water's already in there. In this part of the world, in the wet season, it's bloody full all the time. So it's very wet. So you're going to get a little bit of infiltration to top her up, and then it's all gone. It all runs off. So that water runoff from your paddocks with when the water's full, the bottle's full, that's the thing that's going to start doing the bad erosion in your places, all that water that's running off. So if you haven't got something there to slow and spread that water, you're going to get issues. So once again, in the if it's a dry soil, you can get a lot more differences with your cover and non-cover with runoff. Overgrazing, we've said about overgrazing, and there it is. Your increased runoff from a difference between a basically grazed pasture and a heavily grazed pasture is significant. So while you're, even though you've got a lot of cover on the ground, the more water that runs over the top of that, the more likely you're losing soil and nutrients. Same still with the runoff, the peak flows off properties, the same thing, much higher off a heavily grazed pasture. And you come back to these guys too, it's been mentioned a lot too, the soil biology, soil health. If you've got a lot of cover, you've got a lot of water going in, you get great soil biology, you get great soil health. All these guys can do their work and change that soil cover into humus and then into nutrients that keep topping up that bowl in there for your nutrition. So that's if you keep your soil cover on and your moisture in the soil, you're increasing the capability of these guys to do their job better. So what does it mean for production? Ground cover and nutrients, you can see from this trial, is it's not only water you lose, but you're losing phosphorus and nitrogen. In this landscape, losing phosphorus and nitrogen is bad news because it's a premium. So every bit of water that runs off is taking nutrients with it. And having that difference between 20% and 80% cover is huge. So the little exercise here I did to work out exactly what that means in cattle production. So there was some work done that said that for every millimetre of rain you get between 2 and 10 kilograms per hectare of grass growth. And if you average that out about 4, and you get a 50 millimetre rain, which is about a 1 in 5 year event, over a 1 hour period, you're likely to, if your landscape is rolling about 2%, your runoff from your pasture from bare soil is going to be 50 to 60%, or low cover soil. So you've lost 30 millimetres off that 50. If you've got 90% cover, you're only losing 5 or 10%, so you're only lost 5 millimetres. So your difference is 25 millimetres of rain, 25 millimetres of water that's gone into the dirt that's made a difference if you started with a dry soil. So that's 100 kilograms per hectare of grass. Your cows eat about 10, I think, a day, average 450 kg, man. Tell me if I'm wrong, Jim. So you've got 10 days feed per hectare for one cow out of that rain. And that doesn't sound much. That's okay, better than kicking the eye. But when you look at it over a paddock scale, you get a 50 hectare paddock, that's 500 days of feed for one beast. And then over annual rainfall of 600 mils, or what do you get here, 1,000, 1,200. So, there's 1,200 kgs per hectare per year that you're losing by not having that water going into the ground. So the other thing is about carbon. Increase of 1% carbon in the top 30% of soil, it give you extra 144,000 litres of water per hectare. A lot of water. But as you say, around here, a lot of that, it fills up quick. So it's not quite as critical, but in your dry season, it's very critical to have that stuff. So we talked about infrastructure and how that affects your farm planning and where water runs and doesn't run. So the things that you look at most that you can manage are your fence lines, tracks, fire breaks, and the placement of those things. So you put them on the ridges, the toe slopes, the flats, and on the contour, so that you're not directing water. You're holding water on the country. You're not putting it somewhere fast. If you drain water off fast anywhere, you create erosion, you're losing soil and losing water. So the idea is to slow and spread water with every bit of infrastructure you try to design. Here's a good track positioning along the top of this ridge line. You see the contours there, straight along the top of the ridge line. You'd be losing a tiny bit of water off that track up and down the main slopes. You'd have woe boys on that, so the water channelled or lost from that road would be zero compared to if you had it going across the slope like that, because you'd be harvesting water and running it off. Another one here on the toe slope, around the edges of the slope where it turns to the flat along the creek, and that's an ideal place for tracks. Timber management. Most people like a neat paddock. They love to have things like an oversized lawn. Nice and neat, tree here, tree there, good park. And if you have a stick, you've got to put it in a heap and burn it, quick, because it's making the place look untidy. But if you happen to retain these lines on the contour as a line, you will be holding up heaps and heaps of water. That's nearly as good as a contour bank to hold up water and slow water and spread water. And the added advantage of these guys is all that wonderful biological activity that's happening under there. They're pouring a lot of nutrients in from the activity of the little bit of dirt and topsoil you push into those lines. Cattle can't get in amongst there and eat the seed off the grass if you're in a dry season, so you get a store of seed and you get extra nutrients and you get extra water held on your paddock. So you need to think about shade lines and stick rake lines. They can be really a big benefit. The one thing you've got to remember about that is leave gaps there so you can get the cattle and yourself through. That could be a pain in the butt. So you put them on the contour, as close to the contour as you can. Basic principles, right? Okay, you manage your cover So that's grazing management, grazing distribution with fencing and waters, fencing and facilities. Animal behaviour, same, where the animals graze, how they graze, where they make tracks, where they make cattle pads. Water points are really key to this. If you've got your water points in the right places, you'll be able to direct where cattle pads go. If you've got your shade lines in the right places, you can direct where cattle pads go. Make a lot of difference just with a bit of forethought. Managing water runoff, as has been mentioned, your ground cover is the biggest thing, by far the biggest thing. Keeping on good ground cover and good standover feed for the spring storms and the new wet season. If you've got a 60% tuft of grass there, you've got a way better chance of holding all that moisture in first up and getting the extra grass growth that'll create the 100% cover that you need to hold all your water and soil on. Placement of infrastructure, that's those fences and things, get them on the contour, get them where they're not running water, where they're holding water up. And if it comes to the crunch and you've got some runoff and erosion, you put some physical structures in there like contour banks, diversion banks, pondage banks, whatever you need to do. But when you get to that stage, you probably need to get some advice from some mugs like Jeff and I to say, well, okay, what do we do with that? How do we make those structures so they're not going to just make another problem somewhere else and where they can actually save soil and reduce runoff? I think that's it. Thank you.
Thank you, John. You can take a seat for now. What I thought we'd do next is, so we have heard from Jeff Titmarsh about what drives erosion. Then John gave us a bit of an idea about some of the management methods that exist out there that we can use to reduce soil erosion. And I thought we finished that talk off with Jim again. Where's he gone? Jim? There he is. To highlight the importance of ground cover, but more from a nutritional point of view when it comes to meeting, nutritional value for the cattle throughout the year. So I'll just quickly change the PowerPoint. Thanks to Jeff and John for now. We come back for a Q&A panel after Jim has finished. And we were lucky to have John and Jeff here today because we got extra funding from the Office of the Great Barrier Reef, Department of Resources. So it's always good to have these extra resources. And of course, my role is supported by the Australian government through the National Land Care Program, and we had additional funding from the Queensland government Water Quality Program. And Jim mentioned earlier, often, those governmental fundings seek water quality outcomes, but my role seeks very heavily soil outcomes. And then why is it important? Because it translates into your productivity on farm. And like Jim said, you can't be in the green if you're in the red. I think you mentioned that earlier. It's all interconnected. And I'll just set you up here, Jim, sorry. And today is a great example of collaborating on these different topics and telling you the full picture. Well, I had someone sign for it, but they slacked me off. Okay. So you got your microphone here? Yeah. Clicker? Yeah.
Thanks very much, guys. Thanks, John. Thanks, Jeff, for your presentations. I really think that a lot of the time, all these things interact, our presentations interact. So I was actually looking at this. Is this like, what's the thing down there? I thought it was pretty funny, some of the things that John's saying and was coming up with. It was a little bit distracting, I've got to say. It's coming out like a rap video. Anyway, just ignore that because it's only going to get worse with me. At least John doesn't talk in circles. Sometimes I do. Okay, so now you've got me for round two, and I guess basically what I want to do is bring us back around. I talked a lot about land condition, and I've talked a lot about the things that are driving production in our region and what we're and how to optimise those things. And now I'm going to.
We always like good laugh. Has anyone an idea how to stop this? I don't know what started it.
You're coming out pretty well there. I'm an auctioneer Asian woman.
This must be for
Tech guys, have you got any idea?
since we clicked we done something wrong on that. Yeah, I think it's. Oh, let's try saying something.
Test.
I think we done it.
Oh, there you go. Yay. This is. Oh no. No, it's okay.
Yes, good.
Okay, good. We've cancelled it. Right. Yeah, okay. I'll remember that. Oh. It only listens to you now. That's good. Okay, anyway, we'll progress. Okay, so what I want to do is just bring us back to, so we're managing our grass, or we're not managing it. Oh, it is back. Okay, just ignore it. Just focus on me. I know that's going to be hard with this head, but we've talked about land condition from a sustainability perspective of our...
How about you just look at this screen to keep you on track?
Yeah, okay. Yeah, righto. Do you want us to turn it off?
Oh, well, that you're not distracted by the words.
Oh, it doesn't worry me.
Okay.
I'm rarely distracted. So anyway, so I thought I'd talk a little bit about, so as well as being grassologist, being a extension officer in a large part of the world, you've got to be a bit of a jack of all trades. So the other thing is, we do a fair bit in nutrition, but the case is still the same in that because we're talking about ruminants, a large portion of nutrition is coming from grass. And people want to know about what the special feeds are and what we do for production. But at the end of the day, you've got to be more worried about the 90 percentile, which is basically the grass that's going down their neck. So I'm just going to talk about how land condition, or how looking after your country helps to optimise that nutrition. So, and I start off with another question. What is the most important factor influencing nutrition with ruminants? And I'll get the pregnant lady to run around again, probably, if that's okay.
Yes.
So anybody hazard a guess as that? What is the most important factor influencing nutrition, good or bad, with ruminants?
Just lift up your hand if you want to have a guess.
Availability.
Availability we had.
That's a good word. It's close.
Hang on.
What people have got to get their head around, Jim, is you're not feeding the animal. You're feeding the rumen bugs.
Yes, very good point. We're actually dealing with these animals. These animals are actually, they're not herbivores, they're carnivores. Does everyone know that? They just eat microbes, not grass.
Any other suggestions?
Talk about it later.
Palatability.
Palatability. Yes, I think these two here can combine to form a better word, which I'll talk about in a second. Anything else?
We had multi-species.
So, selection, diversity. Yep. Adds to as well.
Can you repeat that one?
Smith.
What did Sharon say?
Multi-species. Yep.
Just hang on, because I want the people on the YouTube recording catching that as well. So here we go.
Multi-species for not just the green side, but the dry side.
Okay. Smithy, you got one out the back there?
Hang on. Okay, intake.
Oh, he's nailed it. Have you seen this presentation before, Smith? Intake. So we, just like when I asked the question the first time, and it's good that you guys are very close, and you're at least you've got a lot of factors there that you just brought up that combine to produce basically the answer that I wanted, which is intake. Okay? So, the reason why it's important is because, once again, these bovines are just lawnmowers on 4 legs, okay? They are going out in the paddock and they are taking as much grass out of that paddock as they possibly can. They're spending a small amount of time or an equal amount of time grazing, lying down in a tree somewhere, chewing their cud. They also sleep. There's a little bit of time in there for procreation and all the other little things that cows do when we're not looking. And only so that there's more time to eat more grass. So, how quickly that grass goes through their rumen just gives them more time to eat more grass, to put more grass through the rumen, to eat more grass, to put more grass through the rumen. And if you can speed that up to the best of your ability, that equals better production. Okay? So it's all about intake. I don't know what's going on in that photo there. I just found that on the internet yesterday. I was wondering, do they then feed the grass back to the cows? Slightly inefficient system. Okay, so what influences intake? There's a couple of factors here. Intake of these animals that we look after. So the first one is pasture yield, how much bulk we have. If we have more bulk, then we have more selection within that bulk. The larger amount of grass we grow, the more things in terms of, well, overall leaf, because there's more nutrition in leaf than stem, that they can access. If we grow a big sward, it's amazing all the little things that grow inside that sward, protected by large swards of grass, that they will access to improve their selection, which just goes to improving the diet quality and the digest and how quickly it goes through the rumen, which once again improves intake. Stage of growth is very important. So we come to the back end of the dry season. We've been good land managers. We've kept our residual grass there. It's very hayed off. There's a little bit of leaf left, fair bit of stem, mostly hayed off. We get rainfall. What happens? Sorry? In terms of the grass, once we get that rainfall, good enough rainfall, what happens to the grass though? What response do we get in the grass which is brown?
If you know the answer or want to have a guess, just lift up your hand so I can come with the microphone. What was your suggestion again?
It'll break it down if you get enough rain, too much rain on dead grass.
You do get a bit of that, but in terms of the plant itself, in terms of the stages of growth, what happens to grass once the season breaks? From dry affected grass to turns green. It does. It grows. Why does it turn green? What part of the plant's growing to turn it green? What part of the plant is green? The leaf. Yep. So she grows leaf. Leaf then goes through the process of photosynthesis, produces energy, grows more bulk. She grows up. She grows out. She grows up. She grows out. If you manage it, you grow lots of it. So in those initial stages of growth and through to the back end of the growing season, when everything's nice and fresh like it is right now, we have lots of good palatable grass in the first 1 to 2 phases of growth. We say 4 phases of growth. There's early growth. We're currently in about the end of the second phase where we're growing our bulk. Then we've got the hayed off phase. We start to grow seed, and then energy and protein starts to migrate down into the soil, into the roots for storage, for survival, into the seed head for procreation. And then the last stage is basically that dry hayed off final stage where nutrition is quite bad. But right now we are deep into stage 2. We are in good quality feed stage, and so because we have good quality, we have good intake because the throughput is faster. We also have So another thing that affects it is our palatability and species composition. So as we improve our sward, like the lady over here, whose name escapes me, said before, our diversity and our variety of species composition, we improve our overall diet, which improves the intake. Number one, because it's more, it passes through the rumen faster, and it's also of higher quality. Nutrient balance affects intake. In areas where we have, I'll tell you a good example of this, is if we have a paddock with varying land types. If we have some hilly country and a bit of flat, they tend to overgraze the flat country, don't they? That can be because we get a tendency to have an increased sort of pooling of nutrients in that lower country due to water, more silt, more phosphorus, high phosphorus levels. That tends to be, if we manage it well, we get better species down in those lower countries. They access that. Another thing that affects intake is our stresses. If we have large tick, worm burdens, that can influence them in a negative way to have reduced intake. Sick cattle don't eat as much grass as cattle in good condition. Our age and class of animals, older cattle that are more experienced in grazing paddocks that they have a knowledge of, tend to have a higher intake and a higher efficiency in grazing than younger cattle that you put them out in the paddock and they do 18 laps of the paddock before they put their head down to have a feed. Lactation also increases intake. Maybe we get Julia to comment on that. No, just kidding. Keep coming back to the point. It's just a survival mechanism. I think it's pretty self-evident what's going on there. And the other one is water quality. So there has not been a lot of work done on how water quality influences intake in ruminants, but water is common currency in ruminants. Ruminants, they need lots of water within that big, massive system that they use. So there's been a bit of work done from the University of Saskatchewan guy there. So what happens over in Canada, in Saskatchewan and Canada, they get lots of snow. Snow melts. It melts down into these big open dams that they use to collect water. Cattle drink out of the open dams. So you can imagine through the summer. So you can imagine the quality of the dams by the end of summer. So they looked at comparing fencing off these dams and watering out of them versus just letting cattle access that, dung into it, walk through it, all the things that cattle do. And they found that in terms of the older cattle, so obviously things like E. coli and all your adverse things, which are quite adverse to the rumen biome, are obviously elevated in these cattle that are accessing the open dams. Now, it doesn't have so much of an effect on older cattle, particularly older cows. They tend to just get used to it. But in terms of your growing cattle and younger animals, it can have a serious effect on weight gain. So all those things are very important to intake. Now, the first four are probably the most important. And they're also things that you can probably influence to some degree. And the reason why they influence intake is because of this term called digestibility. And I think somebody said palatability before, and that's probably very close to what we are thinking when we use this term digestibility. So basically, there is a direct correlation between how digestible those pastures are, which is linked to all these points, and how quickly it can go through the rumen. Okay? And we can influence all this through our grazing management. They're pretty smart, and their tongue grazers, like I talk about, that tongue has quite a bit of intelligence about it in terms of how it can select things within a paddock that are good for it. So if you can give it that selection, it will utilise that to its gain and yours. So how much does an animal eat? Now, when we talk about how much does an animal eat, we're talking about dry matter. And this can become a bit of an issue in Mackay Whitsunday. And I think we're just coming out of it at the moment. And it's a term that people may have heard of in the past, called basically the green drought. Everyone's heard of green drought? So basically that is all about dry matter. So here's a good example of this steer. He is accessing, this was in February, this signal grass pasture. The dry matter content, that signal grass pasture is currently growing about 14 tonne to the hectare, which is quite good. But that's wet weight. The dry matter content of that pasture was around about 14%. So they had to eat 14 kilos of that, or not 14 kilos, they had to eat, let's say, around about 8 to 9 kilos of this to get a kilo of dry matter, because it was just so much water. So because they had to do that, generally the dry matter intake requirement of that steer would be around about 10 kilos, 10, 11 kilos. But in order to do that, he had to eat somewhere around about 70 kilos of pasture. And that's 70 kilos of pasture there. And they will not do that. So basically it becomes the whole ability to take in that much dry matter, given how much bulk there is in the paddock, is what limits them. And that's why our cattle go backwards a little bit during the wetter months. They can't satisfy dry matter intake. Once again, intake, very important. Okay, but let's just go through this. There's a little bit of maths. So we have one 450 kilogram cow, or that steer. He's probably a bit heavier than 450 kilos. The variation in intake doesn't seem like very much. It's 1.6% to 2.4% of his or her body weight. That's actually a big variation. And what influences it? Once again, digestibility. So that's between 8 to 11 kilograms per day, which equates to around about 3.3 kilograms of dry matter per year. If she's lactating, if she's cow, she's lactating, we increase that by 35%, so it's around about 4 tonne. So it's a lot of feed, and that's why we run out quick if we're not managing it properly. So, knowing that we have this paddock, knowing that we have these bovines, they interact together in a positive or negative manner. What are the nutritional advantages of managing land condition? And I'll go back to that comparison of those two paddocks that I talked about right at the beginning, that were the B and C condition paddocks. Does everybody remember those? That were separated by one laneway fence. Because when we actually looked at these, we didn't just monitor them for land condition, we also monitored them for what nutrition those cows that were grazing in those paddocks pulled out of those paddocks, based on their land condition. So there's our land C condition paddock that I mentioned before. Everyone remember that one? There's our B condition paddock. So what we did, we used a little bit of tech called fecal NIR. We monitored forage, crude protein, dry matter digestibility over a 5-month period from July to November, because that's where we start to get the big variability at the back end of the year. And what we found was this. So in terms of crude protein, these are our two major nutrients for production. Energy, they need energy. They cannot do a thing, you and I, them, all animals that are living on this planet cannot do anything without energy. The other one is crude protein. We can utilise it to synthesise energy, or we can use it as a building block for our bodies. It's pretty important. Now, this is the variation in percentage of crude protein throughout the year. Now, as a rule of thumb, in your pastures, if your crude protein drops below about 7%, you go from efficient to deficiency. The red line was the land condition B paddock. That's how its crude protein went from August through to November. The blue line is the land condition C paddock. Okay, so you can see a variation there in terms of crude protein over that 4 or 5 month period. You can see how it was influenced positively twice over that period due to 2 40mm rainfall events, okay, which helped to buoy those crude protein levels back above deficiency levels. So there was around about, at times, there was around about only 1% crude protein variability, which is not a big thing. The big difference was when we looked at digestibility. Once again, how important is digestibility? Pretty important for ruminants. What we saw is that there was a bigger variation, and this is due to things like the amount of yield present, what was present in the paddock, the species diversity, the quality, all these sorts of things. That's what influenced the difference just between the B and C condition paddocks. Now, right from August, we started to see a variation there of around about 2%. It was buoyed after the 40 mil rainfall, but you can see in the good condition paddock, it plateaued. It held up after the rainfall. Did not do so in the condition C paddock. It dropped away pretty quickly to a variation of around about 4% by September. When you look at that line, across the lean condition B paddock, you see that there's a lot less variability in digestibility between the B condition paddock and the C condition paddock. And that is what you want for ruminants. You do not want their diet going up and down because their rumen efficiency follows that variation, okay? You want to be able to level it out a bit. Very important. So, what does this mean for those cattle grazing the paddocks? The thing that I suppose I want to try and impress upon you guys is that within ruminant nutrition, particularly from a grass perspective, little differences make for big differences by the end of these equations, okay? Little changes in the efficiency of nutrition available and digestibility make a big difference. So what I've done is I've actually picked the variation here between those two paddocks. And I've looked at how much of a difference that is in terms of the nutrition available to the animals. So cows grazing in the land, I've got that wrong. That should be B. Apologies, people. In the land condition B paddock, our dry matter digestibility was 52%. In the land condition, it was 48%. Doesn't sound like much, does it? 4%. But that can have an influence over how much energy or megajoules of energy are available per kilo of that grass, which is once again only 1 megajoule between the two, between 7.5 and 6.5 megajoules of energy per kilo of grass between the B condition and C condition. Once again, not a very big difference. Also, the crude protein, there was a difference of 1%. These sound like small differences, but they can influence on how much the cow eats. So, because the digestibility of the B condition was 52%, cows grazing there would be eating around about 2% of their body weight, which is about 8 kilos. In the 48% digestibility land condition C paddock, they're going to only eat about 1.8. Once again, sound like small differences, but they all add together and start to compound because not only are the cows eating less, but the quality is less. So it all starts to add up. So overall, megajoules of energy intake for those cows grazing the paddock in the land condition B paddock is going to be around about 60 megajoules of energy. In the land condition C paddock, it should be 47. Or around about that, which means we're starting to see the disparity occur in terms of what's available. Overall crude protein intake, 640 grams as opposed to 504 grams. Now, if you are a cow, because that was taken in September, we'd hope that we'd have some cows in there, they're close to calving, so 3rd trimester pregnancy cows in there. Her requirement's around about 67 megajoules of energy and 657 grams of protein. If you've got a paddock in this condition, then you have set your cows up to only be slightly in deficit in the last trimester of growth, so they're losing a small amount of weight. If you add something like a urea dry lick or something like that, a small amount of urea to help stimulate a bit of extra intake, you're actually going to absolve that deficit. So you've got management options there. Unfortunately, in the land condition C paddock, you are 20 megajoules of energy in deficit and 140 grams of protein, which if you want to put it into a feed comparison is around about 2.5 kilograms of M8U per head per day. That's the deficit you've got there for those cows. And that's what you would need to input, something like that, to make up for the management errors that you've made. Okay, and the difference in weight loss on breeders, you're going from 0.1 of a kilo per head per day weight loss to 0.4. And that's why we see late pregnant, lactating cows drop condition very quickly on low condition paddocks. Any questions on that?
Oh no, I was just going to add that yes, I've lost the weight, and then you've put your cows then at risk of not calving. Then when you put your bull in, because they're not at that, like what they need to be to recalve. So you probably cost yourself another calf for the next breeding season because she's too low in condition.
You're 100% right. So what you got your cow on, which is the thing that's one of the animals that's making you money, particularly the pregnant ones, you've got her on the collision course to lose weight. So she is an unsaleable item if she's empty with a calf next year. When you wean that calf and you've run the condition off her, she's empty and too skinny to sell at the meatworks to get rid of. So you've got to hold her over another 12 months if you want to fatten her and get rid of her. And she's empty because body condition score is what drives our productivity in all animals across the northern production systems. Yep, 100%, Jackie.
Okay. Yes. Oh, sorry, I didn't see you there. Just hang on. Here we go.
I just wasn't clear whether Jim's finished or we're going to have more. But I see. Okay. So I'm wanting to congratulate him for putting science directly behind our rotational grazing. Thank you.
I'm sure he appreciates that, so thank you very much.
Thanks very much.
Well,
Thank you.
I had a little walk and talk planned, but we're a bit over time, so I think we move straight into the panel. While we set up, maybe you pair up and spend a bit of time thinking about what's your ground cover condition at home on your farm. Have you seen any signs of erosions? Do you have any questions when it comes to, what can you do at home? And just anything that came up from Jeff's and John's talk, or just the recent one from Jim. Just have a bit of a pair and share again. So those that have just recently joined us, we just coupled up and had a bit of a discussion around what we've learned. And also, consider what's happening on your farm at home and ask your questions. You've got about 5 minutes.